Hello, this is video 62. I'll be talking about the center of gravity. So the center of gravity is the point where the weight of an object can be assumed to act. So what I mean by this can best be explained by looking at this picture that I have here. There's an airplane, and you can see all these arrows here represent the weight of the plane acting downward. The weight of the plane in reality acts everywhere, right? There's mass everywhere on this plane. Well, everywhere there's mass, there's weight. But when you draw a free body diagram for this plane, you don't want to draw a million different arrows, right? So what you can do is you can draw one arrow here that has the same effect as all of the other arrows. So what we're saying is, well, let's pretend that all of the weight of this airplane is centered at this location, and then we can have just one big weight here to replace all of the tiny little weights of every single point in this airplane. So another way to think about this is to think of the center of gravity as the balance point. So if you were to balance a hammer, for instance, well, where would you hold it? Would you try to put your finger right here in the middle? Well, you know, since this end over here with the head of the hammer, since it's heavier, you know that if you were to try to balance it on this point, then it would tip this way, right? So you know that you would balance the hammer at a location that is closer to the heavier end. Well, the location where you would balance the hammer would actually be at the center of gravity. So since this point has the same effect as drawing all of the other little arrows, what this means is that on either side of this point, you're going to have the same amount of force, and that's why it's going to be balanced at this point. You have just as much force making it tilt this way as you do making it tilt counterclockwise on the left here. But it has to be closer to the heavier end so that you're able to have more weight here on the left-hand side to balance out the heavier end. And the last thing about center of gravity is that for a symmetric object, it will lie on the axis of symmetry. So all I'm saying here is if you have a symmetric object, such as a sphere, well, the center of gravity will actually be in the center. If this is a uniform sphere, meaning the weight is evenly distributed, then center of gravity will be right here in the center. So let's do a question. For the center of gravity, we have an L-shaped piece here. Which point could be the center of gravity of this L-shaped piece? So let's assume that the weight, the mass here, is evenly distributed along the object. So you have to think, the easiest way to think is, well, where would be a balance point? And it's funny because it actually doesn't have to be on the object itself. So you know that you can't balance it over here because you have a bunch of weight on the right, a bunch of weight down. This thing would definitely tip. Let's say that you're looking at it from the top view. Well, this object would tip into the page downward, right? So it turns out that the balance point would actually be at location A. You can think of this as the average position of all the weights. You have some weight that is to the right and some weights down. So this and a lot of weight concentrated right here versus no weight here. So that balance point is going to be closer to where the weight is concentrated. So it would be at point A. Then the last thing I wanted to talk about in this video is stability. So this has to do with the center of gravity, because an object is stable if the center of gravity lies over its base of support. So the base of support of an object is whatever area that is underneath the object when the object is just sitting there at rest. So it would be this right here. This would be the base of support here. So you can see that if you extend a line downward from the center of gravity, that it falls over the base of support. And you know that this object here is not about to tip, it's stable. Second case here, we have the center of gravity, and if you extend it, and the arrow is not perfectly, but it's supposed to be right above the pivot point here, so that means that this center of gravity is still above the base of support, which was over here. So that means that this object here will be able to be balanced over this point. But now if it's angled slightly more, now the center of gravity, if you extend that line downward, it does not extend over the base of support, which was over here on the left. So what this means is that this object will definitely tip. It's not going to be stable. So in order to know if an object is going to tip or not, just look at the center of gravity and extend it downward and see if that point is supported. And a very actually fun and surprising easy experiment that you can try at home that I just tried for the first time here and it worked like wonder is take a can of soda and balance it. So there's your can of soda, and there's a little rim here at the bottom, right? It's not perfectly smooth here, there's a little indentation. Try to balance that can of soda. If that can of soda is empty or completely full, it's going to tip over. Can you think why? Because the center of gravity is going to be right in the center, right? If it's full or empty, it's a symmetric object. The center of gravity is not going to be supported. But if that can of soda has a little bit of soda in it, then now the center of gravity will be supported and it'll actually balance, and it looks pretty cool. So that's it for center of gravity. So what we're going to need to be able to use for this topic of static equilibrium that we're going to start talking about is we're going to need to know where the center of gravity acts, and we're mostly going to have uniform objects, so it will act at the center. So you'll be able to draw this location where the weight of the object is going to act at the center. If the object is not uniform, then the problem will tell you where that center of gravity is so that you can draw the weight of the object at that location.